Okay, the graph shows the speed of a car during 50 seconds of motion. So it's speed here, or velocity, time there. What's the speed after 20 seconds? We'll just go up from 20 and across. That's 15 in one square. That's each little square is worth 1, so that'll be 16. That's an easy 1 mark. The acceleration, well, acceleration is the gradient of a distance of a speed time graph. So it's a gradient we want, which is the up divided by the across. If we keep the units, it'll help us here. How far up's it gone in the first 30 seconds? It's gone up 24, and that's gone up 24 meters per second. And how far across has it gone? It's gone across 30, and that's in seconds. And now we do 25 divided by 30, which is 0.8, and then we've got meters per second, which is meters per second squared. So I can sometimes use the units to help me get it right. That's the 2 marks. Distance the car travelled during the 50 seconds, that's the area under the speed time graph or velocity time graph. And so it's got 2 bits to it. It's got this bit here, which is a triangle, and this bit here, which is a rectangle. So it's A plus B equals the distance, and A is the triangle, so it's half the base, which is 30, times by the height, which is 24, and then we have to add the base of the rectangle, which is from 30 to 50, so that's 20 along there, and times the height, which is 24, and that equals first bit's 360 plus 480, and that equals 840 meters. I'm going to work out the average speed of the car in kilometers per hour. Good thing I've been looking at the units during the 50 seconds. So speed equals distance divided by time. And the total distance here we've got is, just worked it out, it's 840. And we've got to divide that, that's 840 meters, and divide it by 50 seconds. And 840 divided by 50 is 16.8 meters per second. And I want it in kilometers per hour. So if I times this by 3,600, that will tell me how many meters there are per hour. So that gives me 60480 meters per hour, and therefore I can divide by 1,000, will give me 60.48 kilometers per hour. You have to decide whether you're timesing or dividing to get that. Okay, graph shows the distance travelled by a van. So we're now in distance in meters. So I got meters per second. Right. Find the average speed in 40 seconds. Give your answers in meters per second. That's nice. It's in right units. So speed equals distance divided by time, and that will equal the distance it's gone. The whole distance is 560 meters. Put the units in, it helps. Divide by 40 seconds, which is that comes to 14 meters per second. And now the final part, worth 6 marks. Show that the van travels at more than 70 miles per hour on at least one occasion. Use this. Well, I'm going to translate this 70 miles per hour into meters per second to start off with. So 70 miles per hour. If I change it into kilometers, that means I'll need to times by 1.6, and that gives me 112 kilometers per hour. And I now want to change this into per second, so I'm going to times it by 1,000, and that equals 112,000 meters per hour. And now I want to, it'll be a lot shorter in per second. And so I divide by how many seconds are in an hour. That'll be 60 times 60, which is 3,600. So if I divide that by 3,600, that gives me 31.111 meters per second. That's the number I've got to compare with. And somewhere in this graph here, the speed must have been bigger than 31.1. To do this, we know that for a distance time graph, the speed is the gradient. So I'm looking at when the line is steepest here, and it's steepest somewhere around about here. So if I draw that line in there, it's meant to be at a tangent to the curve, and now I can work out the gradient at this point here. I'll do all the work on the graph because I'll get all the marks for it, and it's easy to see. So what's it gone up by? It's gone up. That's gone up from 400. And I've got to take away 220, and that equals 180. It's gone up 180 meters, and it's gone across 5 seconds. So the gradient, which is the speed, which is the up or change in y over change in x, that is 180 meters divided by 5 seconds, and that equals 36 meters per second, which is greater than 31. Therefore, Van travelled faster than 70 miles per hour. A little bit squished. The key thing here, though, is to know that the gradient of a speed time thing gives us the acceleration, and you can see the units, meters per second is the upwards bit, the speed, divided by second will give us meters per second squared. The area underneath the graph gives us our distance, and for our distance time graph, the gradient gives us the speed. And you can see again, you can see the units, how they work. And that's question 10 done.